Hello good people, I'm going to talk about writing electron configurations. Previously I mentioned how electrons will occupy orbitals in order of increasing energy. And initially that order is fairly straightforward. So I start with 1s, move to 2s, then 2p, then 3s, then 3p. But now things get more complicated. You would be forgiven if you thought the next orbital is 3d, but it's not. After 3p, we go to 4s, then 3d, then 4p, then 5s. And the further we go up, the more complicated things get. So how can I easily determine in which order the electrons will occupy the orbitals? This energy diagram is okay, but it is a little bit bulky. I need something more compact. And here it is on the right. I have written the orbitals based on the principal quantum number n. So at the bottom I have energy level 1, then energy level 2, 3, 4, 5 and 6. Okay, so how does this help me? Well, I need one more thing. I need some diagonal arrows. And here they are. They go from the bottom right to the upper left. And they tell me the order in which the electrons will fill the energy orbitals. So I go 1s, then 2s, then 2p, then 3s, then 3p, 4s, then 3d, 4p, 5s, then 4d, 5p, 6s, and so on. So let's do a few examples. I'm going to start with phosphorus. So the symbol for phosphorus is P. Phosphorus in its ground state has 15 electrons that I need to accommodate. What will be the electron configuration? I start with 1s and I will have 2 electrons. Then I move on to 2s and I will have 2 electrons there as well. Next one is 2p. There I will have 6 electrons. After that I have 3s and there I will have 2 electrons. Then, according to my arrows, I hit the 3p orbitals. So I have 3p and I will have 3 electrons there, because that will add up to 15. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 13 is 15. Let's do another one. And I'm going to look at argon. Argon has 18 electrons that I need to accommodate. Okay. So once again, I start with 1s, 2 electrons, 2s, 2 electrons, 2p, 6 electrons, 3s, 2 electrons, 3p, 6 electrons. This adds up to 18. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18. And it also makes sense with regards to the phosphorus. Phosphorus had 15 electrons, argon has 18 electrons, so 3 more. And if I look at the electron configuration, the 3p orbital has 3 more electrons when it comes to argon. Let's do one more. I'm going to pick scandium. Scandium is a transition metal. And in its ground state, it has 21 electrons. As before, I start with 1s and 2 electrons there. I move to 2s with 2 electrons, then 2p with 6 electrons, then 3s with 2 electrons, then 3p with 6 electrons. And now where do I go next? Well, I can consult my arrows. So after 3p, I go to 4s. So now I have 4s, 2. After 4s, I go to 3d. And now I have 3d, 1. And that should add up to 21 electrons. 2 plus 2 plus 6 is 10. 2 plus 6 plus 2 is also 10. 10 plus 10 is 20. Plus 1 is 21. Note that there is an overlap between the electron configuration of argon and the electron configuration of scandium. The electron configuration of argon, so this bit here from 1s to 3p, is actually contained within the electron configuration of scandium. How does that help me? Well, now I can write a condensed electron configuration for scandium. I could say that the electron configuration of scandium is the electron configuration of argon, which I indicate by placing the argon symbol in square brackets, and then adding the difference, which is 4s2 and 3d1. I will talk some more about these condensed electron configurations in future videos. That is all for now, and I will see you on the flip side.